Hi everybody, we're back in our Earth Science class, and we're continuing our discussion on matter and energy. It's what makes up our world, those two major components, matter and energy. And so we're going to cover some of that in this PowerPoint presentation I'm going to give you today. Okay, so phases of matter. Phases of matter, we've talked about this in chemistry. You've had it in your earlier classes in middle school, and you've probably had it some with me. We talked about it. Solids, liquids, and gases. And the phases of matter are determined by temperature and pressure. Those are the two components that determine whether or not it's a gas, a solid, or a liquid. Rocks, okay. Liquid, you can see the molten lava there on the bottom, and then the gases that surround that particular planet. Elements can, in these particular ones, these are solid elements, and they compose a good part of our world. Carbon especially. There's carbon in its natural form, and then there's iron. There's a quarter alongside it, and then there's the much valued gold. Okay. And this is a really good look at the percentage of what kind of elements are in our solid Earth. Abundance means the amount of, how many. The abundance of elements, and this is by weight, a percentage by weight in solid Earth. So the crust of our Earth is 46.3% oxygen. Of course, oxygen combines easily with so many other materials, and it combines with silicon and aluminum and iron and all these others. So it's not by itself, obviously, because it's solid. And then so the crust of the Earth, 46% oxygen. Silicon, when we think of silicon, I always think of sand. And there's aluminum, iron, calcium, sodium, potassium, magnesium, and others. And iron, you can say, take a look at the whole Earth, not just the crust, but it's 34% of the whole Earth. That's pretty interesting. And then let's compare that to the abundance of elements, same type of comparison, by weight percentage of living things. Look at that. Oxygen, okay, is 62, almost 63% of oxygen, obviously in combination with other things that make up compounds in our living body. Carbon, hydrogen, nitrogen, phosphorus, and sulfur. Those are all elements. You've seen them on the periodic table. Both those are basic elements that can't be broken down into anything simpler. You can't break oxygen down into something that is not oxygen. If you change the number of protons in it, then you simply change it to a different element. But look at the percentage in humans, and then the percentage in alfalfa, which is kind of a grain, corn, plant material, and then the bacteria. Okay, so we have atomic particles and then atoms. So atomic particles would be the inside of the atom, which is the protons, neutrons, and electrons. Inside the nucleus are the protons and neutrons, and outside are the electrons. And then all those particles make up our atoms, our elements, and then those make up compounds. When you combine elements together, they make up compounds. Now, in this particular case, what I want to point out, let me switch hands here because it's a little easier. Minerals are not living organisms, and we call those we call them inorganic. And so minerals are the rocks which make up the Earth. The organic compounds are the living things, and that is one of the great realms, which is the biosphere, as we saw in that last presentation. So living things, organic compounds, are living things that make up the biosphere. Minerals, inorganic compounds. Inorganic compounds are rocks and crystals and things like that. There's another good example. Minerals in crystalline structure. Sodium and chloride, that makes up salt. That guy right there is salt. That's the compound for salt. So you're actually eating sodium and chlorine mixed together, and it's called sodium chloride or salt. Okay, there's graphite. Graphite, a really nice picture of graphite. Graphite is is what we use in our pencils, isn't it? So they put graphite in the pencils, and we're able to write with it and on paper. Okay, rules of the universe. Let me go back here. Rules of the universe. Conservation of matter. You can't throw anything away. So conserve matter. Sorry, but you can't, nothing can be created nor destroyed. So you can't throw anything away. First law of thermodynamics, which is conservation of energy. You can't get something for nothing. And the second law of thermodynamics, and in fact, you can't even break even. Okay? So you can't even break even, you can't get something for nothing, and you can't throw anything away. Is the Earth an open or a closed system? Meaning, are we pretty much saddled with, what is in our Earth, or do things just come and go all the time, from our Earth? What do you think? Okay? Well, in general, and we're going to say in the main, the large percentage of our Earth is a closed system. Okay? Matter just doesn't come and go from our Earth. It's a closed system to matter. Now, energy does, though, doesn't it? Okay? So, when we say Earth is a closed system to matter, that means that matter is constantly being recycled on Earth, doesn't it? So matter doesn't come and go. It's just being recycled into different compounds from different types of element makeup. And then here are some biogeochemical cycles, reservoirs and pathways. So this is, it goes from atmosphere to hydrosphere, lithosphere, back and forth. They're always constantly going from one to the other, to the other, to the other. Okay? Some of the major cycles of matter, water cycle, water cycle starts, in the ocean. It evaporates, goes up into the clouds, and then in the clouds it condenses into actual water, but it's not heavy enough to fall to the ground. When it gets heavy enough and large enough, then it becomes precipitation or rain, and that's a cycle, and then falls to the ground, then goes into the rivers and streams and oceans, and then recycles again, gets evaporated back up to in the atmosphere, and then it continues its cycle. Then there's the rock cycle. Rock cycle starts with igneous rocks. And igneous rocks are the rocks, as you recall, are born of fire inside the earth, and they're kind of burped up through volcanoes and earthquakes. They come up to the earth, and they stack up one upon another into sedimentary rocks. And then as sedimentary rocks kind of push downward and under heat and pressure, they become metamorphic rocks. And then here are the chemical cycles that we often talk about: carbon, nitrogen, phosphorus, sulfur. Carbon cycle, atmosphere to biosphere. And I point this out because I'm going to show you some pretty interesting deals. Carbon really has a bad image, and everybody badmouths carbon dioxide because we talk about global warming and everything, but without carbon we're pretty much nothing, aren't we? I mean, carbon dioxide is something that we need. And let me show you. Here's carbon transfer. Look at this: photosynthesis, carbon dioxide, okay, and water and sunlight make up sugar and oxygen. Sugar and oxygen. Oh my gosh. So oxygen is replenished in our atmosphere by carbon dioxide in combination with water and sunlight through the process of photosynthesis. And photosynthesis is what plants do to create, their living organism, and it creates sugar, And then, of course, respiration, which is us, biosphere, that's, all of us people. we breathe, and it goes into the atmosphere. And of course, sugar and oxygen, we take in sugar, right? And oxygen, and then we make carbon dioxide, water, and energy. So respiration is the reverse, isn't it, of this whole photosynthesis cycle. Isn't that interesting? I always, when I saw that as a student, I always thought, wow, that is fantastic. So we do need carbon, we need sunlight, we need water. And there's a good look at the carbon cycle. And then Earth. Earth is an open system to energy, but pretty much a closed system to, right, materials on Earth. Mostly open to energy, mostly closed to matter. And that's the presentation for today. This is for my Earth Science students. If you want some extra credit on this, you can always, write me up a little paragraph and send it over to me. You can remember you can send it and drop it off at the school. So hope you're doing well. And that's the second phase of presentation on the great realms or the great natural resources of Earth. Talk to you soon.